Okay. Look at these figures down here. So they look solid, don't you? Yeah, they're three-dimensional figures and they look solid. So these are solid shapes, whilst up here, so these are just plain figures. All right. So you have two types of figures mainly. You have plain figures and you have solid shapes. Now a cuboid, it's like a stick butter. All right, many items that are out there are cuboid. For example, your refrigerator, your TV, your box juice, an eraser, your phone, your TV, your table, your door. There's so many things in your house that is cuboid or cuboid shape. All right. Anybody can give me an example of how of things that shape in the house or the environment or at school that looks like a cuboid? I'm talking about this.
A matches box.
Matches box, right? Anybody else? Just one more.
Sir, dice.
No, you know, a dice is not a cuboid. A dice is actually called a cube.
Oh, yeah.
Right. The difference between the cube and the cuboid is the cube, all sides are what? Equal.
Equal.
Right. All right. Let me tell you something. I don't know if it...
I can't draw a cuboid.
Let me tell you. All right. Tell you. Just do this. Just draw one rectangle, like that, and just extend these out, like that, and connect it like that.
Okay.
All right. So as I was saying, you see, on a dice, say, you see one of those things, they're pronounced, it's called a die. D-I-E. But when you have two, you say dice. So singular die, plural dice.
Oh, okay. So,
yeah, but I mean, you go up on the road and people laugh off you. Say, well, what are you talking about? One die, two die, three die. No. All right. The other thing is what we call a. Oh, by the way, this formula here. Is this formula? So hold on. You have something called area. And you have something called volume. What's the difference? Now, area is talking about how much space is on the flat surface of something. In other words, how much space the right here, so on that flat surface. That's what they want to know. That's what area is all about. All right. You're painting your house, right? You're painting a house. And if you read the instructions on the paint, I don't know if you know this, but when they actually tell you how much space or surface the paint can actually cover. All right. So, for example, one tin of paint. I did some painting over the summer, and I can tell you, one tin of paint would properly paint a room or a section in my my apartment. When I say proper, I mean like, cause you know when someone paint for a long time, you have to get a first coat, let it dry, and then you go again and get another double coat. All right, and when you do that, it looks really awesome. So, and they actually work this out. All right, so you can actually use paint, the calculation for paint, and determine how much you need to cover the surface. All right, you know, for example, I mean, if you let us say you're Butch Stewart, no, not Butch Stewart, like you're Adam Stewart, son of Butch Stewart. Do you know what I'm talking about? Do you know who Butch Stewart is or was? No?
No.
Are you serious? You guys need to know people, you know. You need to know people. All right, Butch Stewart is the owner for sandals. He owns all of sandals. All right. Right. Yeah, man. Cause if you live a flanker or work a hotel or so, you must hear that name before, Butch Stewart. Yeah, man. They said that.
In that what year?
Yeah, he passed away the other day. All right, let's hurry up. So let us say Butch Stewart wants to paint one of his hotels. Can you imagine? You want to paint a hotel, an entire hotel. I mean, you have to do a lot of calculation, not true? And you have to do a lot of orders, and you have to be careful because you don't want to order more paint than what is required. All right, and the area or the surface area of the building comes into play. All right, now area is different from volume. All right, now volume is how much something it can contain in or capacity, the amount of space it can take up. So for example, if let's look at this. I can use this and construct this, not true? Look at this. Would you say that? Would you say I can use this shape and construct this shape? Yes.
Yes, sir.
Yeah, man. So get some metal and construct. No, and you cut it and you open it. No, and you go fill it up with some water. It's a tank you're constructing. So the amount of water that holds in the tank is called as what? Volume. The amount of gas in a gas cylinder is called a volume. All right. The amount of right now, a lot of people with COVID, you find that hospitals are purchasing compressed air or oxygen. All right. So, you know, and the amount of oxygen in a container, you'd say its capacity or its volume. All right. The amount of soda in a drinks bottle, what is it called? Volume. All right. Okay. So this is called a cuboid. Now, to find the volume of a cuboid, it is length multiplied by width multiplied by height. So in other words, you just multiply those three things. All right. Now the other shape is called a cylinder. All right. So when people talk about gas cylinder, you know, the gas cylinder has a cylindrical shape. All right. But tin mackerel, you know tin mackerel? Oh, it look, it has a what? Cylindrical shape. All right. As a matter of fact, most canned foods are what? Cylindrical shape. But come to think of it, all canned foods that I know of are, well, except for sardines and probably tin beef. So tin beef would be like this, not true? And sardines would be like that. But like tin mackerel, milk, baked bean, etc., etc., corn, whatever, is usually what? Cylindrical. Most bottles, alcohol, medicine, are cylindrical. All right. Okay. And the volume for a cylinder is different from the volume for cuboid. It's actually pi r squared h. All right. I must tell you that all these formulas are given in the exam. Page number 2 in your exam paper, they list all the formulas. All right. Okay. So having said that, let us. Any questions, by the way?
Sorry, I can repeat back the definition where you give the area.
Of which one? Oh, you mean definition. All right. So area is just the amount of space for a flat surface. All right. So the amount of space a flat surface takes up is called an area. Notice I stress on the word flat. All right. But volume is the amount of space it takes up for a three-dimensional figure. All right, or what is contained. So for example, for a flat surface, you wouldn't say, how much paint is contained on the wall. You wouldn't say that. You'd probably say how much paint can hold in the tank or water. All right. So having said all of that, let's move on. Let us look at an actual question. All right. So this seems like a long question, but let us discuss it and analyze it. I don't know. You guys, okay, it's 4 minutes. So I'm gonna give you some time to write this off, right? So I'm gonna give you 4 minutes to write this off, right? So when the session ends, I'm gonna resend another link, and that link will be our last session, all right?
Okay, sir. So we must write off everything?
Yes. Or if you want to, you can. No, honestly, I prefer to write off. I prefer for you to write off. So this question is talking about a cereal box.
Sir, so an example of area would be like the amount of space it like one TV screen have or something like that.
Right, a flat surface, right. But if you
And
say
the volume, and the volume would have probably the amount of space a TV take up.
Inside, right. Like inside the TV. Yes, you're correct.
Right.
Right. Oh, TVs, flat screen, those are cuboid too, not sure.
Sir, how are they cuboids?
Well, remember, a cuboid. Look at this figure here. Look at this figure. No, you think about it. Oh, let me tell you. Is it? Okay, I saw what you're saying. I am not thinking along. A flat screen is usually a flat thing, not true? But if you open a flat screen, there's space inside, not true? For the electronics, right?
Yes, sir.
Yeah, man. So it think about it. You see a cuboid, it has to be thick. It has to have a thickness. So when it's a flat screen, you know, I'm talking about the screen, the flat, this is the screen part alone. But maybe when I say flat screen, you're talking about the entire TV. But the entire TV actually have space in it. It's just that it's flat. If you're talking about the new OLED LG wall TV that's paper thin, you can actually peel it off the wall and paste it on the wall. I wouldn't call it a cuboid because it is so thin. All right, but as long as it has a thickness, it's called a cuboid. For example, your phone. If you look at the shape of most phones, it is not thick enough. But as long as there's a thickness, it is a cuboid. So if you look at the screen, just the screen alone, you wouldn't say volume of the screen. You say what? The area of the screen. But the entire phone itself, you say okay, the volume of the phone. All right. I hope I made myself clear. All right. So it's less than a minute. So as soon as it cuts off, please just rejoin quickly. All right. I don't want to waste 10 minutes just waiting on persons. All right. So sorry about that. All right. Now look at this diagram here. Would you say that I can use this to build that? Not true. All right. And if I build this, would you agree with me that the top piece, look at the top piece and the bottom piece, they're the same thing, not true? Look at it.
Yes, sir.
Yes.
Yeah, they're the same thing. All right. If you can't see it, just say go for a matches stick. Not a matches stick, a matches box. Or cornflakes box or any little box and look at it. The top piece and the bottom piece are the same thing. Look at the front piece and the back piece or the back side. They're the same thing, not true? Yeah. So all around this box here is the same thing. All around it. What about the left? Let me draw this thing here again. What about the left part, the left side, and the right side of the box? They're the same thing, not true?
Yes, sir.
But would you agree with me that the left and the right side different from the top, the bottom, the front, and the back
Yes,
side?
sir.
Yeah, they're different, not true? Yeah. Look at a matches box. The part that you open is actually shorter than around the sides. All right? Yeah. You know, talking about matches six, you know, when I was a little boy, I used to give my mother a lot of talking. You know what I used to do? I don't know if you know this, but when I was a little boy, I used to get, you know, the sulfur part of the matches, that part that lights, ignites. I used to like scrape it off, like it's about like an entire box. Scrape it off, and what I'll do is I'll go on the road and I'll get a big nail and get a hammer and punch just like hammer, make a little hole in the road. And what I'll do is that I'll take the sulfur and full up the part that what we dig out, full it up. And what I'll do, I'll try to pack it down, you know, get something, even use the same nail and pack it up. And what I'll do, I'll just insert the nail in the hole with the packed sulfur. All right, you know what I'll do? I'll take a stone or a rock and just hit it, and it will explode like a firecracker. You guys ever hear about anybody doing anything like that before?
Sir, I first met you about that.
All right, so those are the things that we used to do, you know, because we never have apps on our internet, so we have to be out on the road every day playing. All right, so that's a homemade firecracker, by the way. All right, so by the way, don't try this at home, all right, and don't tell anybody that I said for you to try it. Okay. Yes, so having observed all of that, let us go back to the question. All right. So, okay, it says a company makes cereal boxes. All right. By the way, would you agree with me that a cereal box is a cuboid? Yes, it is, isn't true? Yeah. And there's a special name for cuboids. It comes under this. It's called right prism. All right. So, you know, you have other shapes that look like this. For example, how should I say this? No. You know the thing that they use on catch door? It look like that, not true? See that? Like if something is wrong with the door and you want it to be stable, you'll get something like this. That's the only way it would probably stop. So that's also called a right prism. All right, but we're not going into that today. All right, so you notice they give us 3 dimensions. It says each large box has dimensions 25 by 8 by 36. It says calculate the what? The volume in cubic centimeters of one large cereal box. All right, so what are we going to do now? It says volume. Look at this. Volume is what? Length multiplied by width multiplied by what? Height. So what are you going to do? Just multiply all these 3 numbers. All right. So volume for part A, volume it will be just 25 multiplied by what? 8 multiplied by 36. All right. Somebody compute that for me.
Mm. 7,200.
All right. Correct. So the answer is 7,200. No, notice it says it tells you, you know, you see because I'm telling you in cubic centimeters, it means you have to write the unit. You have to write the unit. And that's 3. So volume, it's always 3. Area is 2. It's 2 marks. So you get 1 mark for that and 1 mark for that. Are we clear? All right. Let's look at the next question. It says calculate the what? The total surface area of one large cereal box. All right. So look at this cereal box now. So would you agree with me that all of the sides are rectangular? All the sides of the cereal box, it's rectangular in shape, not true? Right. So, and how do you find the area for rectangle? Length multiplied by what? Width. All right. So look at let's look at the right side. All right. So the 36 would have been the what? The length, and the 8 would have been the what? The width. But would you agree with me that the left side and the right side have the same dimensions? Class?
Yes, sir.
Yeah, same thing, not true? So the total surface area would be 8 multiplied by what? 36. All right, and what I'm going to do, I'm going to times it by 2. Why am I times it by 2?
Color two side.
Right, and because two of them are the same thing. So is it the 8 multiplied by 6 multiplied by 2 represents the area of the right side and the what? And the left side.
So what TSA mean?
Total surface area. Plus, all right, let us look at the front side and the back part, or back side. You know, it's not a bad word here. It's actually the back side of the box. All right, but I think back side is a bad word. But depending on how you sound, or you know, the context, you know, it can sound derogatory or insulting. Can somebody tell me the dimensions of the front part of the cereal box? What is the length and what is the width? Class, come naman.
36, nasa?
Very good. Watch out now. If this is 36, you know, then this is also what? 36, 36, 36. Would you agree? So this,
Yes, sir.
this is also what? 36. So the length is also what? 36. Multiply by the width. What is the width?
25.
25. All right, and then we're gonna times that by what? By 2. And the 2 would represent the front side, the front part of the box, and the back part of the box. Hold on. You know what I want you to do? I want you guys to tell me. I want you to tell me what are the dimensions for the top of the box and beneath the box. What is it? What's the length and the width? That's this piece here.
25.
Mm-hmm.
Or
And what?
the same 25, sir?
I hear something in the background. Say it again.
8 centimeters.
8. You see it? Look, see the 8 there now. See the 8 there? So the 8 is this side. And then times everything by what? 2. All right? So let's run it again. Everybody following?
Yes, sir.
All right. So let's go again. The 8 and the 36 is the left and the right side of the cereal box. The 36 and the 25. No, sorry, hold on. Oh, sorry. Yeah, the 36.
Box, sir, front
right,
and back.
Right. The 36 and the 25 is the front and the back part of the cereal box. All right. And the 25 and the 8 is the top and the bottom piece. All right. So compute this for me, please. And your answer, it's area, so it is centimeter square. Work out that for me and tell me what the answer is. I'm gonna step away for 1 minute. All right. Anybody?
2,776.
All right. Everybody agree? Hold on. Let me check it then, I'm checking it too. Yes, you're correct. Answer is, and very good too, right? Answer is 2,776 centimeter square. All right. Are we good? So that is the total.
Yes, sir.
That's the total surface area of the cereal box.
$2,770.
Very good. All right. Any questions so far? Are we understanding? Any concerns?
Honestly, I just came back in because the Wi-Fi clicked out, so I don't really understand.
Okay, where were you? What was the last part you catch?
Sir, I only wrote up the questions.
Oh, so from them time, oh my.
Yes, sir.
Mercy. All right, tell you what, you have to go check the recording here.
Okay, sir.
It's going to take forever. But basically, what we did, let me just summarize what we did. The question says calculate the volume of the cereal box. All right, and the volume is the capacity of capacity, how much it can hold, and we got 7,200, and we say we must multiply 25 times 8 times 36. So that's part A. of the question, which we just completed a while ago. That's this part here. That's part A. And
Yes, sir.
the second part of the question says calculate total surface area. So in other words, we want to find the area of the front piece, the back part of the cereal box, the top piece, the part that's the area that's beneath the cereal box, the left part, the right part. All right. So, and we all agree that all sides, the shape, it takes a shape of a rectangle, which is length times width. All right. So we just did some math and we just got these. We just multiplied the whole thing and figure out what the values are for the length and the width, and times everything by 2. And we got the total surface area of the box to be 2,776 centimeter square. Notice that whenever we talk about area, surface area, the unit is always 2. All right? Because area, you know why it's 2? Because, let me show you something. Let me show you why it is always 2. Let us say I have a rectangle here, right? And I say this is 3 centimeter. All right, let's use meter. That is 3 meter. No, that wouldn't be 3 meter. I need something a little bit bigger. Let us say this is, say, 6. All right, meters. And over the side here is 2 meter. All right. Now we know that the area is what? Length times width.
Yes, sir.
Which is going to be 6 meter multiplied by what?
2
meter.
2 meters.
But you notice that anytime we're doing this calculation, we always are left off the letter, not true? All
Yes,
right?
sir.
But if this was algebra, we say, okay, 6m times 2. Think of algebra. 6m times 2m will give us what? 12m. What is m times m in algebra?
M square.
M square. Yeah. That's how we get square. That's basically what we did. Because there's an imaginary one there, and then another imaginary one, and when you multiply with the same base, you add the index. All right? And area is a two-dimensional something. So anytime we talk about area, it is always square. Now you see with the cube at 3 something multiplied and through. So it's like you're gonna have 3 centimeter, 3 centimeter, you have 3 centimeter. So centimeter times centimeter times centimeter will give you centimeter what? To the third power. All right. So
Yes, sir.
okay, so let's continue. Well, you know, say, come next, just one question we can do. But it's a good workout, you know, and I'm sure you learned something today. All right, so let's move on now. So we have covered. By the way, this is a CXC past paper, you know? All right. So this is A, and this is B. All right, check out C now. No, C is common sense. It says, think. When you read something, try to think about what it says. It says, the cereal from one box. All right, from one large box. By the way, this is a large box. What we're looking at is a large box. Agree? It says the cereal from one large box can exactly full up. Let me use part one. Full up 6 little boxes of equal volume. So basically, what am I trying to say? You have one big box of cereal. All right, and that big box. You know those small little cereal box? Those little tiny ones. I think that's what they're talking about. You guys ever seen them before? Like cornflakes, some little small.
Yes.
Yeah, honest to God, I don't know why they make them. Because I don't know why they make them. I don't know if it's snacks or what, but I don't know. I don't know. All right, but anyways, but basically what I'm trying to say, one big box of cereal can fill up 6 little one. Question is, calculate the volume of one little box. How would you do that? Yeah, man, go ahead.
Me probably wouldn't just like find the area, the total area for the entire box, and probably divide it by 6. Divide it 6 times.
All right.
Like that.
You're almost correct. Who want correct? On an area. It's not area.
The total volume.
Volume.
Right. Remember saying, our inside of the box, You understand? All right, think about it. Imagine you're at home, right? Your parents buy what KFC you got? 12 piece? What you have 12, you have what? 9 piece? As I go? Why lowest one? 9? Or 12? I don't know. 12 piece KFC meal deal. Alright? And daddy bought, you get one 2-liter soda, not true? Alright? And let us say we have 10 cup. Let me make it a bit easy. Let us say you have one liter Pepsi, all right? And you have 2 big cup. You have 2 big cup, and the 2 big cup. So the Pepsi in the 2 big cup, it full them up exactly. All right. So in other words, those 2 little cup, would have been what? Half liter, not true? Yeah. Because those 2 half liters will not give you back what? 1 liter. I hope you're following me. Are you following me?
Yes, sir.
Yeah, man. So basically, and it's because it says you throw them out and they're equal and full up equally, you're just going to divide everything by 6. So it's going to be 7,200. So part C, part 1, 7,200 divided by 6, which is how much that?
12 something. 1200.
It'll be 1,200. It's volume, not true? So it's still what? Centimeter what? Cube. And this is the volume for one what? Small box. All right. In other words, six of those small box would have full out the big box. Would you agree? Yeah, man. All right. So when you're doing planning, party planning, or events planning, catering, you have to do something, not true? Yes, man. When you're planning a little party, you need to know how much drinks to buy, not true? Yes, you have to. Planning a wedding or even funeral, I don't know. Goes both ways, not true? All right. Last part, and this will end the class. It says if the height of the small box. All right, so let's draw a little box here. So this is one little box, one little cereal box them. the box here. This is like that. All right, so that's our little small box, right? Them says what? If the height, so the height is 20 centimeter. Oh dear. Sorry about this. If the height is 20 centimeter, list two different pairs of values which the company can use for the length and the width of the small box. In other words, you tell me, what are they saying? How do you interpret that? Anybody? Wait, everybody gonna sleep? All right, let me just run it.
So I understand, sir.
All right, look. Is it a small box? Okay, what do we know about the small box? We know so the volume of the small box is what?
1200.
1200, right? Them say, if the height, by the way, how do we find the volume of a cuboid? Length multiplied by what? Width multiplied by what? Your height, not true?
Height.
Right, so you what? Them give you the what? The height. The height is what? 20.
20.
And them say, they want two numbers to go right there, so. So that when you multiply this number and this number times 20, you get back what? 1200. That's what they want. You follow? So
Yes, sir.
what are those two numbers?